Okay folks, we're just going to look at the solutions to exercise sheet 7. Question 1 is revision and what we were doing in sheet 6. Things like quotient rule, product rule, chain rule. Question 2, we're looking at higher derivatives. Number 3 is just an application in that. Number 4 is implicit differentiation. Number 5, we're looking at the equations of tangent line and normal line using differentiation because it corresponds to the slope. So we can use the equation of a line formula. And then the last 2 questions are in practical problems and that, okay? Okay folks, so to quickly recap on the rules, we're going to use the number 1 and further down the sheet at times as well. Remember, the product rule is if you get the product of 2 functions u and v, then the derivative is given by the first function u times the derivative of the second function v plus the second function v by the derivative of the first function u. Okay, so it's the first function by the derivative of the second plus the second by the derivative of the first. Quotient, if we're dividing 2 functions into each other, then the derivative is given by the end function by the derivative of the top minus the top function by the derivative of the end, all over the end function to be squared. Okay folks, so if we look at number 1, it's the quotient rule, okay, so it's the end function which is x cubed by the derivative of the top, differentiate e to the x, we get e to the x, minus the top function which is e to the x by the derivative of the end, differentiate x cubed, we get 3x squared. E to the x is common to both of the expressions, so I've got x cubed minus 3x squared. If you want, you can take out x squared there by factorization, so we have x squared into x minus 3, because that gives us x cubed minus 3x squared. What x squared will cancel with x squared underneath the line to leave us with x to the 4 underneath the line. Okay, we could have done it just spelling it out with u and v as well, and cross multiply and so forth, okay. So it'd be v times u, would be these 2 first, then minus the product of the other 2, all over v squared. Part 2 is the chain rule. Remember, that says if we have a function of a function, we take the outer function first, differentiate that. So if we're differentiating sign of an expression, we'll get cos of the same expression back, so we'll get cos of everything back. Then multiply your answer by the derivative of the inner function. The derivative of x squared minus 5x plus 1 is 2x minus 4. Okay, that's what's involved in the chain rule. We've seen plenty of examples on that in sheet 6. So if you have any doubts, maybe go back and look at the last question, question 4 in sheet 6. Product rule, x squared plus 3 times sine x. Well, it's the first function, which is x squared plus 3, multiplied by the derivative of the second one, derivative of sine is cos, plus the second function, which is sine x, times the derivative of the first, differentiate x squared plus 3, and we'll get 2x back. Okay, so that's what we should have for part 3. Again folks, there's typed up solutions of these in your Moodle page as well, okay. Part 4, quotient, so it's the second function which is x squared plus 1 by the derivative of the top, differentiate x squared minus 2x plus 5, we'll get 2x minus 2, minus the top function which is x squared minus 2x plus 5 by the derivative of the end, differentiate the end function here, we get 2x, because the derivative of 1 is 0, all over the end function to be squared, multiply out on top, so x squared by 2x is 2x cubed, x squared by minus 2 is minus 2x squared, 1 by 2x is 2x, 1 by minus 2 is minus 2, and here we've got 2x by x squared is 2x cubed by minus is minus 2x cubed, 2x by minus 2x is minus 4x by minus is, 2x by minus 2x is minus 4x squared, by minus is plus 4x squared, and 2x by 5 is 10x, by minus is minus 10x. The 2x cubes will cancel, these two. With 4x squared minus 2x squared is 2x squared. 2x minus 10x is minus 8x and minus 2. Then it's all over the end part to be squared. And if you want to, you can take 2 out as being common here. Part 5, we're actually combining product rule and chain rule overall. It's a product, okay? So it's the first function, which is x squared minus 4 by the derivative of the second. But when we're differentiating the second, we're applying the chain rule, okay? Because it's the sine. If you differentiate sine of an expression, you get cos of the expression back. And then multiply your answer by the derivative of the inner function, which is 3. Okay, and then I'm just bringing the 3 to the front here in the next line. And then the other part is the second function by the derivative of the first function, differentiate x squared minus 4, we get 2x. And that gives us what we want, okay? That's the first 5 parts of number 1. Okay folks, part 6 is just a little bit more involved. We've got a quotient. Again, we're dividing one function by another, but each function is a composite in the quotient. Okay, if you want to let u be the top one, sine 3x plus 1, v is the end one, x plus 7v squared. So when we're getting du dx, again, remember, if you differentiate in the composite, differentiate sine, we get cos back, so we get cos of everything back, 3x plus 1. Then multiply your answer by derivative of 3x plus 1. The derivative of 3x plus 1 is 3, so that's where that's coming from. The other part, x plus 7 to the 5, differentiate that. The outer function is to the power 5, so bring down the power, take 1 away from the old power. So we'll get 5 times the same expression in brackets to the power 4. Multiply your answer by derivative of the inner function. If we differentiate x plus 7, we're going to get 1 back. And then that's just 5 times x plus 7 to the 4. And we're subbing in, so v times du dx is a product of these two. V times du dx is the product of these two. That's v x plus 7 to the 5. Du dx is 3 times cos x plus 1. So we're multiplying these two together. Minus u times du dx is a product of these two. Okay. And again, if we look at that, and then it's all over v squared. So v squared is x plus 7 to the 5 all to be squared. If we look above the line, x plus 7 to the 4 is the common power, because we got it to the 5 and to the 4, so x plus 7 to the 4 is a common one, so it's factorization. We take out the smallest power. Then we're left at 3 times x plus 7 by cos of 3x plus 1, because we need an x plus 7, because x plus 7 by x plus 7 to the 4 will give us the x plus 7 to the 5. In the end part here, we got 5 times sine x, we got 5 times sine 3x plus 1, and when we multiply that by x plus 7 to the 4, we get the original part back. Index numbers a to the p to the, a to the p to the q is a to the power p times q. We multiply the powers together, so 5 by 2 is 10, so we have x plus 7 to the 10. We have x plus 7 to the 4 over x plus 7 to the 10, so we can see that's the same as x plus 7 to the 6. It's 10 minus 4, which is 6. Okay, so that's the end of number 1 in sheet 7. Okay folks, look at number 2. Number 2 is quite easy. Higher derivatives just means you're differentiating again. So if this is our function y, the first derivative, the one we normally do, dy dx, means you're just differentiating that, bring down your power. So it's going to be 3 times x to the power 2. Minus 2 by 2x is minus 4x plus 5x. Goes to the number, when you differentiate number times x, you get the number back. Second derivative just means you're differentiating the first derivative. Any higher derivative, you're differentiating the previous one. So if we differentiate this again, we get 3 by 2x is 6x. Number times x goes to the number. Third derivative, we're differentiating the second derivative. So differentiate 6x, we get 6, number goes to 0. Relatively easy because they're just powers of x. Okay, so there's nothing new. All it means is you're differentiating the previous derivative to get the next derivative. Okay, next one, y is 3 times sine x plus 4 times e to the x plus 5 times ln x. Differentiate once. Sine goes to cos, so 3 times sine goes to 3 times cos. E to the x goes to itself, so 4 times e to the x goes to 4 times itself. Ln x goes to 1 over x, so 5 times ln x goes to 5 over x. We can write 5 over x as 5 times x to the minus 1. Remember that there are the rules of indices from last year. X to the minus 1 is the same as 1 over x. The advantage about writing it like that is then you can differentiate it using the power rule. Okay, so if we look at the next line, second derivative, we're differentiating the first, so cos goes to minus sine, so 3 times cos goes to 3 times minus sine, which is minus 3 times sine x. E to the x goes to itself, so 4 times e to the x goes to 4 times e to the x. Last part, 5 times x to the minus 1. We bring down the minus 1, so we're going to get minus 5 times x to the minus 2. I take 1 away from the old power. Minus 1 minus 1 is minus 2. If you want, you can write that as minus 5 over x squared. So that's giving us the second derivative. If we want to jump on from there to get the third derivative, we're differentiating the second one. I'm just switching the order to bring the positive value to the front. So e to the x goes to itself, so 4 times e to the x goes to 4 times itself, e to the x. That doesn't change. Sine goes to cos. So minus 3 times sine goes to minus 3 times cos. The last one here, the 5 over x squared, we're better off looking at 5 times x to the minus 2. Remember, we have a minus in front of us, so when we bring down the power minus 2, we're multiplying that by minus 5 to get plus 10. And then we're taking 1 away from the old power, so if you take 1 away from minus 2, you get minus 3. So that's where the 10x to the minus 3 was coming from. And finally we can write that as 10 divided by x cubed. Okay folks, part 3 of number 2 is a composite function. So when you differentiate sine 4x, remember the derivative of sine is cos, so we get cos of 4x back. Multiply your answer by the derivative of 4x, which is 4, and we're done. Second derivative, we're differentiating this, so we're going to get 4 times whatever the derivative of cos is, because remember you always get the number back if you're multiplying by that. Differentiate cos, we get sines, we get minus sines, we get minus sine of 4x back when we differentiate that. Multiply your answer by the derivative of the inner function. The derivative of 4x is 4. So 4 by 4 is 16 by minus is minus 16 sine 4x. Third derivative, we're differentiating the second derivative. So again, we've got our minus 16 in front because we're multiplying by that. Sine goes to cos, we get cos 4x back. Multiply your answer by the derivative of the inner function. Differentiate 4x, we get 4. So 4 by minus 16 is minus 64. And we cos 4x, okay? Part 4, we're using the product rule. Again, we've this function by u by v, 3x minus 2 by e to the x. Remember, it's the first function by the derivative of the second. Differentiate e to the x, we get e to the x itself, plus the second function, which is e to the x, by the derivative of the first. Differentiate 3x minus 2, we get 3. Looking at that, e to the x is common, so bring it outside. So we 3x minus 2 times e to the x plus 3 times e to the x. So 3 and minus 2 is plus 1, so you can see that's gone up by 1. That's gone up by 3 from 3x minus 2 to 3x plus 1 times e to the x. Next time around, when we're differentiating, it's the first function, which is 3x plus 1 by the derivative of the second, e to the x is itself, plus the second function, which is e to the x by the derivative of the first. Differentiate 3x plus 1, we get 3. Same principle, take out e to the x as common factor. So we 3x plus 1 times e to the x, and we 3 times e to the x. So 1 and 3 is 4. So again, you can see we've increased by 3 times e to the x. So 3x plus 4 times e to the x. Differentiate again using the product rule. So it's the first function, which is 3x plus 4 by the derivative of the second one, e to the x, plus the second function, which is e to the x by the derivative of the first one. Differentiate 3x plus 4, we get 3. And again, to the x goes outside. So we 3x plus 4 times e to the x. And with 3 times e to the x, so again 4 and 3 is 7, so with 3x plus 7 times e to the x. Number 3, we're just trying to show a result. We're trying to show this is true in the case of number 3 when y is sine 7x plus 3, so we need to differentiate to get the first derivative and differentiate again to get the second derivative and then sub in. Okay, so if we differentiate once, sine goes to cos, we get cos of 7x plus 3 back. Again, remember, you multiply your answer by the derivative of the inner function. Differentiate 7x plus 3, you get 7. So dy dx is 7 times cos of 7x plus 3. We need to get the second derivative, so we're differentiating the first. So again, we get 7 back because we're multiplying by that. Cos goes to minus sine. So we're going to get minus sine of 7x plus 3 back, everything back. And then again, multiply your answer by the derivative of the inner function. Differentiate 7x plus 3, you get 7. So we 7 by 7 is 49 by minus is minus 49. And we've sine of 7x plus 3. So if we sub into the expression, we're putting in minus 49 times sine 7x plus 3 for d2y dx squared. 49 times y is 49 times sine 7x plus 3. So we've one expression is minus the other, so if we're adding the two of them, we get 0 back. Okay folks, number 4 is implicit functions. Implicit functions are where you don't know the explicit relationship between y and x, so you can't just differentiate an expression of x. The relationship is there implicitly in the way it's written out. Okay, so in a case like that, we're treating y often as a composite function, like we'll see here. So let's just look at it separately. So what we're going to do is differentiate both sides. So if we'll start with the x terms and worry about the y ones in the end, because the x are what we normally get. So if we differentiate x cubed, we get 3x squared. We differentiate x squared with respect to x, we're getting 2x. Differentiate 2x, we get 2 minus 5 goes to 0. The y terms, we just don't know y explicitly as a function. So if we're differentiating y with respect to x, that's just what we mean by dy dx. So we're getting dy dx back. So we've got 3 in front, so we're going to get 3 times dy dx back. Here we've got y to be squared, so it's like a composite function. We're squaring another function, so if we're differentiating, the rule is we start with the outer function, which is a power, so we bring down our power, which is 2, take 1 away from the old power, so we're going to get 2 times everything back to the power of 1. So we're going to get 2 times y, or twice y, back to the power of 1. Okay, we bring down the 2, take 1 away from the old power, so we're getting twice y to the power of 1. Multiply your answer by the derivative of the inner function. The inner function here is y, so the derivative of y is dy dx, so we're multiplying our answer by dy dx. We then group the dy dx's on one side and everything else on the other, so I'm going to subtract 3 times dy dx across. So I've got the dy dx's on one side of the equation. 3x squared, I'm adding it, so I subtract it across. I'm going to factorize this. Dy dx is a common factor, so I'm taking that out. And I have 2y minus 3, because you multiply dy dx by 2y, you get 2y dy dx. You multiply dy dx by minus 3, you get minus 3 times dy dx. That's all equal to the right. So I have 2y minus 3, I'm multiplying by that, so I divide across by it. We end up with that expression there. Okay, so dy dx is equal to that. Part 2, we have this function in part 2. So again, if we're differentiating both sides with respect to x, let's look at the x terms first. So x to the 7, bring down your power, which is 7, so 7 by 3 is 21, by x to the 6, because we're taking 1 away from the old power. X cubed goes to 3x squared, 5x, number times x goes to the number, minus 7 goes to 0. Y plus 1 to be squared is the composite function, so we've got a power on the outside, so bring down our power, which is 2, take 1 away from the old power, so what's in the brackets doesn't change. So we twice y plus 1 to the power of 1. Then multiply your answer by the derivative of the inner function. If you differentiate y plus 1, you're getting dy dx for the y part, and 1 goes to 0, so we just get dy dx back. This is a little bit easier because we have only one dy dx term, so we subtract 21x to the 6 across. Then we're multiplying dy dx by twice y plus 1, so we divide across by it, and that's our answer. Okay. Folks, number 5 is quite doable. Get the equation of a tangent line and normal line at a point. So we got the function, so we're going to differentiate a 1. So if we differentiate that, x cubed will go to 3x squared. 3x squared will go to 3 by 2x, which is 6x, minus 4x will go to minus 4. So that's what the derivative is. The usefulness of that is if you sub in the point into the answer for the derivative, you get the slope of the tangent line to the function at that point. So at the point 1, 7, x is 1, so I'm going to put 1 for x. I got 3 times 1 squared plus 6 times 1 minus 4. If you work that out, we get 5 back. So we can say the slope of the tangent at 1, 7 is equal to 5, because we're getting 5 back. Okay. So if we want to get the equation of a tangent line, the normal equation of a line is y minus y1 is m times x minus x1. We know m, the slope of the tangent line at the point, is 5, so I'm putting in 5 for m. The point itself is 1, 7, so I'm putting in 1 for x1, 7 for y1. And if we multiply that out, 5 by x is 5x, 5 by minus 1 is minus 5. So if I subtract y across, add 7 across, I get this expression here. So 5x minus y plus 2 equals 0. So that's slope of tangent line, easy enough. So you're just using dy dx and subbing in the point to get the slope of the line. If dy dx had included... Yes, hi folks, I'm just, so when we, if dy dx had y terms as well as x terms, we would have subbed in 7 for the y terms at this stage, okay. And that would only be if the function was implicit. Okay, a normal line is perpendicular to the tangent line, so if we know the slope of the tangent line is 5, so remember the slope of the tangent line is 5. Remember, 5 equals to 5 over 1, so that'll give us the slope of the normal line. Remember, if it's perpendicular, we just invert, so it's going to be 1 over 5, and change the sign. That was a plus, so change it to a minus. So that's where the minus 1/5 was coming from. Let's do perpendicular lines, which we dealt with in the early on in this semester. Okay, so use the equation of line formula again. We're putting in minus 1/5 for m. x1, y1 again is at 1, 7, because we went to normal line at that point. We're going to multiply across by 5 here, leave the minus on the left, so 5 times y is 5y, 5 times minus 7 is minus 35, minus x is minus x, minus 1 is plus 1. I'm adding the x across, I'm adding the well, I could have added 35 across at the same time, so I would have x plus 5y is equal to 36. I could do it in 2 steps like what I did there. Okay folks, that's number 5. Folks, number 6 is a very easy question, just once you're clear on what the actual question means. Okay, so maybe just put the question back up for a second. So number 6, we've got software company just released a new product onto the market. Their analysts predict the monthly sales Q will be given by Q as 400m minus 10m squared, and the monthly sales will behave like that for the first 40 months after the launch. Okay, M represents the number of months. Use differentiation to show the sales are increasing after 10 months but decreasing after 30 months. I mentioned in class, if the derivative is greater than naught, it means sales are increasing. If the derivative is less than naught, it means sales are decreasing. So the first thing we need to do is we need to differentiate 400m minus 10m squared, and then we can sub in m equals to 10 and m equals to 30. So we should find when we sub m equals to 10 and we get a positive answer. When we put in m equals to 30, we get a negative answer. Okay, so just looking at that, so we've got our function here. Differentiate once, so a number times m, you're going to get a number back, which is 400, minus 10m squared, bring down your power, which is 2, so we minus 10 by 2 is minus 20, take 1 away from the old power, we get n. After 10 months, put in 10 for m, so we're going to get 400 minus 20 by 10, which is 400 minus 200, which is 200, that's greater than naught. So it means the function is increasing, the function in this case is sales, so sales are increasing. After 30 months, put in 30 for m in dq dm. So we can get 400 minus 20 by 30, which is minus 600. Get minus 200 as our answer. The derivative is less than naught, which means the function sales is decreasing. Okay, so relatively easy, very, very easy, just subbing in your values. Number 7, just finally, if I just look at number 7, jet's moving along an airport runway. At the instant it passes a marker, it begins to accelerate for takeoff. From the time it passes the marker, its distance from the marker is given by s. Remember, s represents distance, t represents time, where s is 2t squared plus 3t. Distance s is measured in meters, t time in seconds. Find the speed. Remember, speed is given by ds dt, so find the speed of the jet when it passes the marker, when t is naught. So you find ds dt, sub in t equals to naught, then jet must reach a speed of 83 meters per second for it to take off. After how many seconds will it reach the speed? How far is the jet from the marker at that time? And find the acceleration of the jet. Quite an easy question if you know what you're doing, because the function is simple enough. So just to look at it in terms, first of all, to get the speed, we differentiate the function. So if you differentiate 2t squared, you're going to get 2 by 2t, which is 4t. Differentiate 3t, we get 3. But we're looking for the speed when t is equal to 0. When it passes the marker, t equals to 0. So we're putting in 0 for t. So we get 4 times 0 is 0 plus 3. So we're left with 3. Our units are meters per second. You can write that in that form, or ms is minus 1. Okay. Second part, I was saying the jet needs to reach a speed of 83 meters per second for it to take off. And after how many seconds does it reach that speed? So we have our expression for speed here. When we differentiate it, so we're letting that equal to 83. So if I got plus 3, so I'm going to subtract it across. I get 4t is 83 minus 3, which is 80. 4 times t, so I'm going to divide across by 4 to get t is 80 over 4, which is 20 seconds. So after 20 seconds it reaches that speed. How far is the jet from the marker at that stage? Well, sub 20 into the distance formula and I'll tell you how far you're away. So I'm putting 20 in for t here, so I've got 2i's 20 squared plus 3 times 20. 20 squared is 400 by 2 is 800, plus 60 is 860 meters. And finally, the last part, we're looking for the acceleration of the jet. Acceleration is just a second derivative. Okay, so we found the sdt. The first derivative is speed, is 4t plus t. The second derivative is acceleration. Differentiate that again. We just get 4 times t goes to 4, and that's it. Again, remember your units are meter per second. Your units is meter per second squared, or ms to the minus 2, because it's the rate of change of velocity, and velocity was meters per second. So expressing that relative to time again. Okay, folks, that's the end of sheet 7.